Hello my dear students, welcome to my today's lecture, that is chapter number 1, differentiation of the class 12. In today's lecture I am starting with exercise number 1.1, and from this question number 3 I am starting with the 9th question. I have completed 8 questions from question number 3 of the exercise number 1.1. Let us see what is the question number 3 and the 9th question from this question number 3. Let us see here. Given question is y is equal to cot of log of x by 2 minus log of cot of x divided by 2. Differentiate this y with respect to x, we get dy by dx. First, take the derivative of this cot of log of x by 2. Derivative of that means d by dx of cot of log of x by 2 minus d by dx of log of cot of x by 2. Derivative of this cot is minus cosec square of x. This is minus sign, minus of cosec square log of x by 2 into the derivative of log, that is the inside function log x by 2. Take the derivative of this log of x by 2 minus 1 upon derivative of this log is 1 upon cot of x divided by 2, and multiply with the derivative of the inside function means cot of x by 2. Then minus cosec square of log of x by 2. This is the first derivative of the first function, and multiplied with the derivative of this log of x by 2, that is 1 upon x, the derivative of log of x, and 1 upon 2 is the coefficient of this log of x, therefore 1 upon 2 into 1 upon x. This becomes minus, this 2 becomes denominator of denominator becomes the numerator, therefore it becomes 2 by cot of x, and the derivative of cot of x divided by 2 becomes here 1 upon 2 into derivative of this cot of x is minus cosec square of x. And last is simplification of this minus cosec square of log of x by 2 divided by this 2x, 2 into x is 2x, plus this minus becomes here plus minus cosec square, and this minus becomes this plus cosec square of x. This 2 and this 2 get cancelled. 1 upon cot means tan of x. The final answer becomes dy by dx is equal to cosec square of x into tan x minus cosec square of log of x by 2 divided by 2x. This is the final answer of the 9th question. Okay. Let us see the 10th question. Here, the 10th question is y is equal to 2 e raised to 2x minus e raised to minus of 2x divided by e raised to 2x plus e raised to minus of 2x. First, students, take the simplification of this. We get e raised to 2x divided by nothing but there is 1 minus sign between them, and 1 upon e raised to 2x. Because of this negative sign we have to take this in the denominator. Then in the denominator we get the index positive, and in the denominator of this function is always also e raised to 2x plus e raised to minus of 2x. It becomes e raised to 2x plus 1 upon e raised to 2x. Then on simplifying these terms, we get y is equal to e raised to 4x plus 1. That is, we take the LCM of these two and LCM of this denominator also. Therefore, e raised to 4x plus 1 minus 1, this becomes minus 1. E raised to 4x plus 1. This is of the type of derivative of u upon v, and we know the rules of the differentiation from the my first video of this that is rules of the differentiation. Then u upon v, the derivative of the denominator and the numerator, that is keep the denominator v as it is and take the derivative of the numerator du by dx, minus u keep as it is means the numerator keep as it is and take the derivative of the denominator dv upon dx divided by v square. This, by using this rule, we have to differentiate the given function, that is y is equal to e raised to 4x minus 1 divided by e raised to 4x plus 1. dy by dx becomes e raised to 4x plus 1 into the derivative of e raised to 4x minus 1 minus e raised to 4x minus 1 keep as it is and take the derivative of the denominator, that is e raised to 4x plus 1. In the denominator, v square becomes e raised to 4x plus 1 bracket square divided by, okay, then next term e raised to 4x plus 1, e raised to 4x plus 1 into derivative of this e raised to 4x is e raised to 4x and e raised to 4x derivative of this 4x is 4 minus e raised to 4x minus 1 keep as it is and take the derivative of this bracket, that is e raised to 4x plus 1. E raised to 4x derivative of this is e raised to 4x and multiply with the derivative of 4x is 4 and divided by the denominator is same as it is, that is e raised to 4x plus 1 bracket square. Take common e raised to 4x into 4 outside of the, then 4 into e raised to 4x outside the bracket. In the bracket, its remaining terms are e raised to 4x plus 1 minus sign e raised to 4x, this minus minus becomes plus 1 and e raised to 4x minus e raised to 4x get cancelled out, plus 1 becomes 2. Then last term is 4 into e raised to 4x into 2 divided by e raised to 4x plus 1 bracket square. Then the final answer is e raised to 4x into 4 into 2, that becomes 8, that is e raised to 4x plus 1 bracket square in the denominator. That is the final answer. Okay. Next question. Practice students, otherwise it is very difficult to you without practice. Okay. Therefore, practice it and practice it. Okay. Let us see the next example, that is the 11th example. Just like the 10th example, y is equal to e raised to root of x plus 1 divided by e raised to root of x minus 1. Then differentiate this with respect to x, we get dy by dx is equal to, use here similar to the 10th example u upon v formula, that is the rules of the differentiation of the quotient. Okay. Then the denominator e raised to root of x minus 1 keep as it is and take the derivative of the numerator, that is e raised to root of x plus 1 minus keep the numerator e raised to root of x plus 1 as it is and take the derivative of the denominator e raised to root of x minus 1 and divided by v square. V means e raised to root of x minus 1 bracket square. Okay, students, get it? Let derivative of this e raised to root of x plus 1, e raised to root of x, derivative of is, it becomes e raised to root of x. Take the derivative of this root of x is 1 upon 2 root of x. Multiply with the derivative of raised to root of x, that is 1 upon 2 root of x. My plus 1 is the constant, therefore the derivative of this is 0, therefore nothing to write. There is no need to write it. Okay. Minus this bracket is keep as it is, that is e raised to root x plus 1 keep as it is and take the derivative of e raised to root of x minus 1 e raised to x root of x, that is as it is, derivative of this is as it is, that is e raised to root of x. We have seen already the standard formulae of the differentiation. Okay. Into derivative of this root of x is 1 upon 2 root of x multiplied with the derivative of this root of x, that is 1 upon 2 root of x, divided by the bracket square as it is. Take common from this all terms, that is e raised to root of x common from this, and in the denominator this 2 root of x keep in the denominator. In the numerator this bracket and this bracket, middle sign is minus sign. These two brackets on simplifying we get e raised to root of x minus 1. This minus sign goes to the e raised to root of x. This minus and this plus becomes minus 1, and this becomes get cancelled out, that is minus and plus terms, and divided by 2 root of x, bracket into the bracket, it becomes e raised to root of x minus 1 bracket square. And the final answer is that is minus 1 becomes minus 2. E raised to root of x, remaining terms is e raised to root of x divided by this 2 root of x into e raised to root of x minus 1 bracket square, and the final answer is equal to this 2 and this 2 get cancelled out, and is equal to minus of e raised to root of x divided by root of x into e raised to root of x minus 1 bracket square. This is the final answer of this example number 11. Okay, it is similar as the 10th example. You also practice it, students, and get the formulas of the standard formulas of the derivatives of the given functions, okay, and the composite functions also. Next, going to the 12th example of this exercise, first we go through the laws of the logarithms, that is first law of the logarithm, that is log of m into n, it becomes log of m plus log of n. We have to need to the 12th example the laws of the logarithms. Therefore I first explain you what are the laws of the logarithm. These are the basic laws of the logarithms. Therefore it becomes log of m by n is equal to log of m minus log of n. We need in the logarithmic differentiation also. Therefore I first explain you the laws of the logarithms. When two functions are multiplied, then the logarithm of these functions gets is equal to log of m divided by log of n, and when the quotient becomes log of m by n, it becomes log of m minus log of n. The third law, that is equal to, that is log of m raised to n, it is equal to this raised to n exponent becomes down to the power of this m, okay, n into log of m. These are the some basic laws of the logarithms. Okay, students, you get it? First you learn about this and study about these laws of the logarithms, and we have to solve the 12th example of this exercise number 1.1 and from question number 3. Okay, let us take the question number 12, that is y is equal to log of tan cube of x into sin raised to 4 of x into x square plus 1 bracket raised to 7. These are in the terms of m, n, l, suppose. Okay, we have to use the first law of the logarithm, that is y is equal to log of tan cube of x sin raised to 4x, and the last bracket is x square plus 7 bracket raised to 7. Then y is equal to, it becomes log of tan cube of x plus second, that is n, suppose log of n plus log of sin raised to 4x plus l, suppose log of l, that is x square plus 1 bracket raised to 7. These terms are as type the third law of the, that is log of m raised to n, it becomes log of 10 raised to 3x. This becomes n n means this 3 into log of tan of x plus sin raised to 4 becomes there, this 4 becomes here, 4 log of sin of x, this 7 becomes here, and n into log of m as like, therefore 7 into log of x raised to 2 plus 7, this bracket. Okay, then after simplifying this, we have to differentiate the function. Then differentiate this y with respect to x. We get, okay, dy by dx is equal to 3. Keep as it is. Take the derivative of this log of x, tan of x, that is 1 upon tan of x, and multiply with the derivative of the inside function, means tan of x. Derivative of tan of x plus the second term is 4, keep as it is, and take the derivative of log of sin x is 1 upon sin, and multiply with the derivative of this sin of x, plus 7, this is constant, therefore keep as it is and take the derivative of log of x square plus 1, that is 1 upon x square plus 7, and multiply with the derivative of x square plus 7. Then 3 into 1 is 3 by tan x, 3 upon tan x, it becomes, into derivative of tan x is sec square of x plus 4 upon sin x, into derivative of sin x is cos x plus 7 upon this x square plus 7, and into the derivative of x square plus 7 is 2x. Okay, this becomes, on simplifying, we get 1 upon tan. This 3 keep as it is, and 1 upon tan means cot, and cot means cos by sin. Clear, students? What is here? 3 keep as it is, 1 upon tan means cot, and cot means cos upon sin, into sec square of x is becomes 1 upon this cos square of x, plus 4 upon sin x into cos x. Cos by sin means cot x. This 4 keep as it is, cos upon sin means cot of x, plus 7 into 2 is 14x divided by x square plus 7, and after simplifying, the final answer is dy by dx is equal to what? This is the final answer, that is 3 into this 1 upon sin means cosec x. This 1 cos can get cancelled, and 1 upon cos is remaining, and this becomes 1 upon cos means this becomes sec of x. 1 upon sin means it is becomes cosec of x. This 3 keep as it is, 1 upon sin means cosec x, 1 upon cos remaining is cosec of x. This cosec x into sec of x, this is the first term. And second one is becomes 4 cot of x, plus third is 14x divided by x square plus 7. Okay, students? Okay, consider all the examples and solve it. You try it, otherwise practice it, and learn about and study about the formulas, different types of the formulas of the composite functions, standard formulas for the derivatives of the standard functions. Okay, use the rules of the derivative differentiation of, we have already seen the rules, standard formulas, composite functions. Okay, then from the exercise 1.1 I have completed from the question number 3 total 12 questions. Okay, students, thank you, and what are your queries? Tell me and discuss it very frankly, and thank you, students. Okay.